All right, so in the first question, we need to find the inverse of this function. F of x equals x minus 3 over x plus 4. So if you want to find the inverse, the first step is to switch our x and our y. And then we want to isolate our y. I'm going to start by cross multiplying this over because we got to get rid of y's in the denominator first. I'm going to multiply this x into this bracket. Then I'm going to move my y terms to one side and all the rest of the terms to the other side. So I'll do xy minus y equals to negative 4x minus 3. I'll factor out a y over here now. And then I'll divide both sides by x minus 1. So I have negative 4x minus 3 over x minus 1. And you can actually write this as f inverse of x in this step. One other thing to remember is this can be written in a different way. For example, you could factor out the negative from the top. So you could also write this as negative 4x plus 3 over x minus 1. And technically, this is a finished solution. But if you can't find a multiple choice that matches for these, you can also factor a negative out from the bottom. And then the negatives just cancel. So you're just left with 4x plus 3 over 1 minus x. But technically, all these three are good solutions in the question. For question number 2, I have an equation that is f of x equals x e to the 2x, and I have to find the intervals of concave up. So in order to do that, I have to find my second derivative. Let's start with the first derivative, f of f prime of x. I'm going to find that using my product rule. So f equals to x, g equals e to the 2x. F prime is just 1. G prime for an e function is the exact same thing. Then I multiply by the derivation of the exponent for my chain rule. That's just 2e to the 2x. So f prime x is just f prime times g. So 1 times e to the 2x is just e to the 2x plus g prime times f. So if I multiply these two terms here, it's just 2x e to the 2x. I put the x before the e to the 2x just to make it a bit more simplified. Now that I have this here, I need to find my second derivative. So in order to do that, I'm going to have to derive this function first. So derivation of this is just e to the 2x times 2. And then the derivation of this will again require product rule. So f equals 2x, g equals e to the 2x, f prime equals to 2, g prime equals e to the 2x times 2, which is 2e to the 2x. And I'll put f prime g here, 2e to the 2x plus g prime times f. So that's 4x e to the 2x. I can simplify this. That's just 2e to the 2x plus 2e to the 2x plus 4x e to the 2x. And I can continue here on the bottom. I'll combine these two like terms. So it's just 4e to the 2x plus 4x e to the 2x. Now I need to make this equal to 0 to solve for my inflection points. Whenever I have an e in my equations, I want a common factor. My largest common factor is 4e to the 2x here. I'm left with 1 plus 4x. So e has no solution. Over here, my solution is x equals negative 1 over 4. So I'm going to put these on a number line. Negative 1 over 4. I'll pick a value less than this and sub it into my second derived equation. So if I pick negative 1 and I sub it here, this is going to be positive, but this is going to be negative, which means that this is concave down. If f double prime is negative, it's concave down. I'll pick a value greater than this. I'll pick a 0 here. E to the power of 0 is 1, so this is positive. 1 plus 0 is 1. Positive, positive means it's positive, so this is going to be concave up. So my intervals of concave up for this function are from, I just realized that is just an x, not 4x, because I factor out a 4, so this is just negative 1. Negative 1. So if I sub in negative 2 into this equation, this is going to be positive, this is going to be negative, so that's still concave down. And if I plug in 0 into this equation, that's going to be positive, that's going to be positive, still concave up. So my intervals of concave up are basically from negative 1 till infinity. Third question, I have a demand equation. And I need to find the elasticity of demand when x is equal to 9. I need to find whether the function is elastic or inelastic. So my elasticity of demand equation is just p of x over x p prime x. The first thing I want to do is I want to derive this function, but before I derive it, I'll throw in my square root into x to the power of half. Now I can derive this. So 40 just disappears. Negative 2 times 1 over 2 is just negative 1. And my new exponent is going to be negative half, which is basically negative 1 over x to the power of half. So now I can sub it in my elasticity equation. So that's just 40 minus 2 root x divided by x times negative 1 over x to the power of half. And now I can sub my x value in, which is 9. So I have 40 minus 2 root 9 over 9 times negative 1 over 9 to the power of half. You can calculate this, so that's just 40 minus 2 times 3 over 9 times negative 1 over 3, which is just 34 over negative 3, or basically negative 34 over 3. Now that I found this, I need to determine whether it's elastic or inelastic. So remember, you always take the magnitude of this. So the magnitude of negative 34 over 3 is just 34 over 3. And since this is greater than 1, it's going to be elastic. So if the magnitude of your solution is bigger than 1, it's elastic. If the magnitude of your solution is smaller than 1, it's inelastic. Fourth question, we have an equation x cubed y minus 3x y squared plus 4x minus y equals to 1, and we need to find dy over dx at 1 comma 1. So this is implicit differentiation. So I have two functions here, so I'm deriving with product rule. So f is equal to x cubed, g equals to y. Remember, anytime you derive a y term, it turns into y prime with the chain rule. So f prime is just 3x squared, and g prime is just 1 times y prime, which is just y prime. I can put this in my equation, f prime g, that's 3x squared y, plus g prime times f. So if I multiply these two, I just get x cubed y prime. I want to derive this term here again, it's product rule again. So f equals to negative 3x, g equals to y squared, f prime is negative 3, g prime is 2y, and then with chain rule, I have to multiply it by y prime. So I'll continue here, f prime times g, negative 3y squared, plus g prime times f, oh, that's a negative, so 2 times negative 3 is negative 6, and I have x, y prime. Derivation of 4x is just 4, and derivation of negative y is just negative y prime, and derivation of 1 is just 0. So now I can isolate my y prime terms. So I'm going to move everything else to the other side and keep my y prime terms on this side. So I have x cubed y prime minus 6xy y prime minus y prime equals negative 3x squared y plus 3y squared minus 4. Then I want to common factor out a y prime here. X cubed minus 6xy minus 1 . Then I want to divide this on the other side. And again, these steps were not totally necessary. You could technically sub in the point into this equation, but just in case you had to find the derivation, I want to show it like this. This is the same as dy over dx. And now you can sub in the 0.11 to find what the answer is going to be again. But remember, it might be quicker to just sub it into this step and calculate from that point as well. So now I'm going to sub in 1 for x and 1 for y. So I have negative 3 plus 3 minus 4 over 1 minus 6 minus 1, which is just negative 4 over negative 6, which is 2 over 3. Okay, question number 5 is a limit question. Lots of different types of limit questions, but in this one, we have a square root x minus 1 over root x minus 1. If I sub in 1 into this equation, I get 0 over 0, which is indeterminate form. So I have to rationalize the denominator in this case because that's what my square root is. I'm going to multiply the top and bottom by the same thing here, but I'm going to change the sign. So times root x plus 1 times root x plus 1. You'll keep the top in factored form, never simplify the top in this case. So it's just like that. For the bottom, you want to FOIL out the two brackets. So root x times root x is x. Root x times 1 is plus root x. negative root x minus 1, and the two middle terms just cancel out. So you're left with lim x approaches 1, x minus 1 root x plus 1 divided by x minus 1. And now we can cancel these out. We're just left with root x plus 1. Now I can sub in my limit of 1. So that's just root of 1 plus 1, which is just 2. Next question, we have to evaluate the following improper integral. So integral of infinity to 1, 3 over cube root x dx. So before we integrate this, we can simplify it. 3 over x to the power 1 over 3 dx, and then we can simplify it again. 3x to the power of negative 1 over 3 dx. So now I'll integrate this. I'm going to add 1 to my exponent. It's going to become 2 over 3, and then I'm going to also divide by 2 over 3. I'm going to simplify this. So 3 divided by 3, 2 over 3 is just 9 over 2. And then when we sub in infinity for our first limit, we just have infinity minus 9 over 2. I'm going to sub in my second limit 1 over there, which is basically just infinity. Basically, infinite integral, or basically the integral diverges. Next one again is an integral. So we have the integral of 2, 0 x over x squared plus 1 dx. So this one looks like we have to either do substitution or parts. If I derive the top, I will not get something similar to the bottom, but if I derive the bottom, I'll get something similar to the top, which means this is integration by substitution. I'm going to make u equal to the bottom, and I'm going to find the derivation of this, du over dx equals to 2x. And then I'm going to isolate du. Oh, I guess I'm going to isolate dx. So du, I'm going to cross multiply these over 2x equals dx. So now I can rewrite this as integral, my first limit 2, if I plug it in this equation, 2 squared plus 1 is 5. Second limit, 0 squared plus 1 is just 1. I can not replace x with anything, but I can replace x squared plus 1 with a u, and then I can replace dx with du over 2x. Now the two x's cancel off, and I'm just left with integral 1 over 2u du. So all I have to do is integrate this function, sub in my limits, and I'll get my answer. So if I integrate this, the integral of 1 over u is just ln u. So I just have ln u divided by 2, the limits of 5 and 1. Now I'm going to sub in my limits into this. So I have ln 5 over 2 minus ln 1 over 2 ln1 is just 0, and 0 divided by 2 is just 0. So that's going to disappear, and my final answer is just going to be ln5 over 2. Question number 8 is again another integration question. So we have integral ln to 0 x e to the x dx. So if I try to integrate this, if I derive this function, I do not get this one, and if I derive this function, I do not get this one, which means you cannot use substitution here, which means the only option is to use integration by parts. So integration by parts, the equation is, let me look this up really quick. Integral u dv equals to uv minus integral v du. So when you pick your u and your dv for parts, you want to make sure that the one you pick as dv is easy to integrate. Now, both these functions are easy to integrate, so it doesn't matter which one we pick as u and which one we pick as dv. But in some questions, it will matter, so definitely keep an eye out for that. The easier to integrate function should always be picked as dv. So here I'm picking my u as x. I'm going to pick dv as e to the x dx. I'm going to first derive this over here. So u prime, I guess I'll write as du over dx, makes it a bit easier, is just equal to 1. And over here, I'll move the dx to the bottom. So dv over dx equals e to the x. Now I'll integrate this. It'll turn into a v, and the integration of e to the x is just e to the x. And I can sub this into my equation. I have u times v, so I have x times e to the x minus integral of v, which is just e to the x times du. So I'm going to isolate my du here by cross multiplying that dx over. So du equals to 1 times dx, which is just dx. So du is just dx. Now I'm going to integrate this over here. So I have x e to the x. Integral of e to the x is just e to the x. Then I'll put my limits on the outside, ln 2 and 0. I'm going to sub in my limits into this now. See what I get. So if I sub in ln 2 here, I have ln 2 e to the power of ln 2 minus e to the power of ln 2. And then if I sub in 0 into this, this is just going to turn to 0 because 0 times anything is 0. And then e to the power of the 0 is just 1. So I have 0 minus 1 for this one. E to the ln 2, the e and ln's just cancel, and you're just left with 2. So this is 2 times ln 2. This is just 2. And then I have minus negative 1, which is plus 1. So my final answer is just going to be 2 ln 2 minus 1. I just combined these two like terms. Okay, question number 9. I have find f of 0. F prime x equals to x to the power 1 over 3 minus 2. And f of 8 is 4. So again, this is a pretty easy one. I want to start by just integrating this equation so that I get f of x. Integration of this is just x to the power of 4 over 3. I add 1 there, divide by the same exponent, 4 over 3, minus integration of 2 is just 2x, and then I'll put a plus c at the end. Now I'll just simplify this a bit. I'll make this 3x to the power 4 over 3 over 4 minus 2x plus c. The next thing we want to do is we want to find our c. So to find our c, we're going to sub in this point over here that's given. My y value is 4. My x value is 8. Eight to the power of 4 over 3, that's just 16 because cube root of 8 is 2, and then 2 to the power of 4 is 16. Sixteen divided by 4 is just 4. 12 minus 16 plus c. 12 minus 16 is negative 4, so my c is basically 8. So I can rewrite this equation as f of x equals 3x 4 over 3 divided by 4 minus 2x plus 8. And now the question asked me to find f of 0, so I just have to sub in 0 into this. This is just going to be 0, 0, so the final answer is actually just going to be 8.